Good morning, everyone. As you know, today we have a great deal of material to cover, and therefore, I think we will skip the introductions and move right on to tackling this subject of risk management. If you have questions along the way, please feel free to interrupt me by raising your hand, and I will gladly ask my assistant, Mr. Janeri, Chief Consultant at Compliance House Incorporated, to step in and attempt to clarify matters for us all. Oh yes, by the way, the harp noise that you hear is my way to indicate that we are switching slides. So, in this presentation we will cover 4 things. First, we'll start with a brief discussion of what risk management is all about. Then, we will provide some motivation for why we do it. After that, we'll get to the meat of it all and walk through how we do risk management. We will conclude with examples of how the results of our process are used in the context of a computer system validation project. As a side note, I should warn you ahead of time that many of my analogies relate back to my all-time favorite subject, which is food. So it is only fair to say that it is my objective to whet your appetite for learning more about risk management. Whenever we are asked to do something we are not familiar with, there always seems to be some concerns, hesitation, and even some pushback. This is natural because we don't feel confident until we know more about this new thing. In our case, both here and across the industry, people are struggling with what it means to have a risk management process. It is really just fear of the unknown. The good news is that it is not that difficult to do. In fact, we've already been doing it most of our professional lives. What is different here is that we're now being asked to explain our process and document our results. Indeed, if we have a repeatable process to follow, and that process is documented in a standard operating procedure, all we need to do is get everyone trained on the procedure, follow the procedure, and then write down our results. Consider the baker's analogy. Sure, when all of the chefs emerge from the kitchen, everyone is interested in the end result, that is the cake. But from the agency's perspective, they would like to have some additional insight into how we arrived at our end result. They want to know the recipe and the ingredients that we used to make the cake. For the person who is trying to understand how you came to certain conclusions and who is trying to understand the rationale for the decisions that were being made, the real thing of value is what process you followed and what inputs were needed for that process. Our risk management SOP describes the process as well as the inputs, including tools, methods, information, and people resources that we need to get to this result. Before we go any further, we need to define some basic concepts that are used in the risk management procedure. Risks are a part of every system. They are a part of every decision we make, and they are a part of every activity that we perform. To say they don't exist is absurd. To say they exist is trivial. A kitchen blender can shock you, it can fall off of the pantry shelf and hit you smack on the head. And if you are not too swift, it can tear your bloody fingers clear off. You can't deny them, because all of these are risks that are built into that kind of appliance. Risks can originate from any of the 5 basic facets that comprise a system, including hardware failures, software errors, human error, which itself could be brought on by inadequate training or fatigue. They could be brought on by incorrect documentation, and like our blender example, risks could be realized if the device is not properly located or fielded in a suitable environment. You will hear people talk about risk analysis, risk assessment, impact analysis, and several other buzzwords. The approach that we have chosen follows the NIST and ISO standards, where the overall discipline for handling risk is called risk management. Risk management includes a way to identify the risks, an assessment of the identified risks, some form of action plan to remediate the risks, and as time marches onward and things change, a way to monitor the risks. Needless to say, some risks will outweigh other risks, so our method has an added feature of prioritization, so that we may attend to the most glaring and critical risks first. Also, as we have mentioned, all of this needs to be properly documented. So what do we mean by risks? In the context of this discussion, risks are tied to losses, damage, and generally those types of events or situations that we want to avoid. It could be a data integrity risk, where the loss, accidental deletion, or corruption of a critical data file could occur. It could be a safety-related risk where someone in the lab or a patient is injured. It could be a project-related risk, where inadequate resources could derail an otherwise well-defined project. Or it could be a business-related risk, where the company faces the potential for pissing off a customer and losing an account. There are all sorts of ways to characterize and categorize risks, which will be useful to help us organize our thoughts. We will return to this idea of using categories of risks in a moment. Our definition, which follows the industry standard, looks at two aspects of risk: the likelihood that a risk event could occur, and the severity of that risk, or the damage done by the risk manifesting itself. Let's first talk about the likelihood of a risk occurring or not occurring. It turns out that in order to make any reasonable predictions about a risk event actually occurring, we would need to have historic data, such as failure rates and system reliability. Unfortunately, when it comes to computerized systems and software, there is very little hard data that we have on hand, since we don't keep this type of quantitative data around. That is not to say that we can't estimate the likelihood in some way, but it does mean that we are left with making likelihood estimates based on best engineering practice, and based on our experience with a particular system, including our technical knowledge of how the system works. As far as the other component of risk, that is severity, the same notion applies. We have to assign qualitative estimates of how damaging the loss situation is to our business. With severity, however, we often have a clearer and more intuitive understanding of the types of incidents that can happen, which can help us make our estimates a bit more realistic. It is important to point out that, beyond just the immediate impact of a risk, severity has a time component and a spatial component. So it may be necessary to further delve deeper into understanding the consequences of the risk occurring. This, of course, all depends on the type of risk event that we are talking about. A toxic chemical spill or release of poisonous gas in a laboratory could have longer-lasting effects if people are exposed to the fumes, not to mention the time to clean up the mess. In terms of the spatial component of severity, one can easily imagine the impact of a fire, where the smoke damage could be inadvertently circulated through the ventilation system, thereby adversely affecting a much larger part of the population in your facility. But then the question arises, when do we stop? That is, when have we conjured up enough risks? What makes sense to include as a risk and what does not make sense? When is enough enough? I mean, really? Are we going to be concerned about an asteroid smashing into our facilities at Research Triangle Park? I think not. When we say that we want to identify something like risks, this automatically implies that we know what we are looking for and we know where to look for it. If you look in the wrong places, you are simply wasting your time. That's why it is useful to constrain the space where we will be looking, which will greatly reduce our discussions about risks. If the medical device world has taught us anything, it would be that we should be concentrating on reasonable kinds of events and, moreover, only those sorts of events and situations that are foreseeable. So we can initially say that we are only interested in reasonably foreseeable risks. But we can go one step further in constraining this space by limiting ourselves to only those risks that apply to our intended use of a product or system. This will depend on what we want from the system and how we intend to use the system. For example, The risk of having an internet virus penetrating our computer network can be effectively eliminated if we are willing to entirely isolate the company's computer network by not permitting any access to the internet. But in most companies, this solution is not reasonable. As we will see, it is all a matter of making trade-offs and decisions to balance the kinds of functions and features that we want to have and use in our computer systems. I've rambled on now for some time and need to run off to get a snack. While I'm gone, I trust you will give Mr. Janeri the same courtesy that you have given me. John will cover a few of the terms that are used in our risk management SOP, as well as an explanation of the main processes of risk identification, risk assessment and analysis, and risk mitigation and remediation. When I return, perhaps after taking a quick nap, I'll make some concluding remarks and I will pass out the test at the end of this seminar. Thank you for your attention. John, would you kindly turn the video off? Thank you.